Okay, question 8. Find the second moment of area for the cross section. Ooh, this would normally take quite a while, but you should notice that this thing, it has a centroid bang in the middle. It's a nice symmetrical I-beam for you. So it should be straightforward. You could use the table method, maybe just some simple calculations. Up to you. Do some accountancy, see if you can find one of these numbers, and I'll see how I can do. So when you're ready, press play. Okay, painful stuff. Where's the centroid here? Centroid is actually what I really want to do is do I equals sum of. I'm thinking there's probably a cheeky little method, a void method you could apply here. So I'll just show you both. So the first way would be to say we got these three sections. I'm gonna do some power. What would I do first? Probably the BDs divided by 12 terms and the parallel axis theorem terms. I noticed that the top is basically a reflection of the bottom. So I can sort of double my calculation for the bottom one and then have one calculation for the middle one. So I could say 2, and let's just look at my bottom section. So we've got 2,135 times by 30 to the power of 3 divided by 12. So that's the first bottom section. We're just carrying on with the BDs. So the middle one, you notice I've got 2 there because I'm doing a reflection, top and bottom. Now the top one, middle one, sorry, it's 50 by 50. So that's going to give me 50 to the power 4. 50 times 50 to the power 3 gives me 50 to the power 4. Now the AHs. Now the middle section is at the same location as the centroid, so it hasn't been displaced at all. So there's no H there. The only one that I'm looking for is what's the distance from here to here? Right, well, the distance from here to here is going to be 30 plus 25. So that gives me 55. The distance from here to here will be half of 30, which will be 15. So the distance from here to here will be 40. Okay, so the H, I make it to be 40. That's the only place where I can think I might likely go wrong. So this section here has been displaced by 40 millimeters going from this position to that position. The area of this is the 135 times 30, but don't forget I'm doing a mirror reflection, so need to do it twice, so 2 of them. So 2 of them, and that will be 135 times 30 times 40 squared. So that should give me my I in terms of millimeters. 2 times 135 times 30 to the power of 3 divided by 12 plus 50 to the power of 4 divided by 12 plus 2 times 135 times 30 times 40 squared. Yeah, 40 squared. Okay, so that gives me 14.1 times 10 to the 6, and that's in millimeters. The other way that you could do it is you could do it using the void method. So we imagine that we've got a big box, Everything then is located on the centroid. So our I would be the big box, which we'll call big B, big D to the power 3 over 12. And then we've got these two sections here, which are two smaller boxes, and their centroids are also lining up. We need to take them away because they're void. So 2 minus 2, little b, little d to the power 3 over 12. So the big B is 135. The big D is 110. Okay, and now the little b is this distance here. What is that? So we've got so I'm going to take the 135 divided by 2 and take away 25. And so that gives me 42.5. Yeah, way I could have done it would have been imagine these two sections glued together and not done the two. Okay, so that's the B. Now the D is obviously 50 to the power 3, and we want to divide that by 12. 135 times 110 to the power 3. What I'm going to do is I can do all these numbers and then divide by 12 at the end, minus 2 times 42.5 times 50 to the power 3. And divide that by 12. And yes, I get the same answer. 14.1 times 10 to the 6. It's 0.0888, but round it up. So both methods give me the same answer. Is there an option? Okay, so done it to 4 decimal places. This one here, D, should have chosen.